Hello and welcome to all students. This is SYBSC class, SYBSC semester 4, paper number 1, calculus 4, unit number 1, Riemann integration, and today we are uh, going to solve some examples on Riemann integration. Let us take question number 1. Show that show that integration over 0 to pi by 2 of the function x upon x dx upon a into sin x plus b into cos x greater equal pi upon 8 into square root of a square plus b square okay. So we have to prove this inequality. So let us write the answer of this question. Okay. So we know that a into sin x plus b into cos x is equal to, so if I make some adjustment like this, a square plus b square inside the bracket a upon square root of a square plus b square into sin x plus b upon square root a square plus b square into cos x okay. And let us put a upon square root a square plus b square equal to cos alpha, and put b upon square root of a square plus b square is equal to sin alpha. Then above equation becomes a into sin x plus b into cos x is equal to square root of a square plus b square into sin of x plus alpha but we know that sine theta is always less equal 1 for all theta. Theta belongs to the set of real number. So instead of this, if I put 1, then we have the inequality. So this implies a into sine x plus b into cos x is becomes less than or equal to square root of a square plus b square. Okay, now taking reciprocal, we get 1 divided by a into sine x plus b into cos x greater than or equal to 1 divided by square root of a square plus b square. Okay, square plus b square. Square plus b square. Okay, so just multiply by x to this inequality. Multiply by x to this inequality, what we get is x divided by a into sin x plus b into cos x greater than or equal to x divided by square root of a square plus b square plus b square. Okay, and then integrating this inequality, over 0 to pi by 2, then what we have is integration over 0 to pi by 2 of the function x dx upon a into sin x plus b into cos x, it is greater than or equal to integration over 0 to pi by 2 into x divided by square root of a square plus b square dx. Okay, so the integration on the right hand side we write here, right hand side is greater equal, so let us take outside 1 upon square root of a square plus b square is outside of the integration, and we take the integration over 0 to pi by 2 of the function x dx. Okay, again we write see here, so this step is not less equal, this step is equal to the above step, and again we write is equal to 1 divided by square root of a square plus b square. Okay, and The integration of x is x square by 2 0 to pi by 2, it is equal to 1 divided by square root of a square plus b square, and for the upper limit what we have is pi by 2 square by 2. Okay, pi by 2 square by 2, and for the lower limit we get the 0 value minus 0. It is equal to, so finally we get it is pi square upon, see here, pi square upon 8 into square root of a square plus b square. Okay, and this is the required thing. Okay, thus finally we have the required inequality, integration over 0 to pi by 2 x dx whole divided by a into sin x plus b into cos x, and it is greater than or equal to pi upon 8 into square root of a square plus b square. Okay, so this is the required inequality we have proved. Okay, let us go to the question number 2. Second question, question number 2. Second question, prove that, or we write here, show that show that 1 divided by 3 root 2 is less than or equal to integration over 0 to 1 x square dx whole divided by square root of 1 plus x less than or equal to 1 upon 3. Okay, for x greater equal 0 less equal 1. Okay, we write the answer of this question. Okay, so we start with, okay, so we know that in the range, okay, we know that this thing 1 plus x, this quantity 1 plus x is always greater equal 1 and less equal 2. Okay, when x belongs to place 0 comma 1. Okay, so x belongs to 0 comma 1. So we take this inequality and try to prove the given inequality. So how to prove it is very simple. Okay, so for that what we will do, first we take a square root. Okay, taking square root. So if I take a square root, inequality will remain as it is. Okay, so let us take square root on. Okay, square root of this side is 1 less equal square root of 1 plus x and less equal square root of 2. Okay, then what we will do, now let us take a reciprocal. Taking a reciprocal, so if I take a reciprocal, then inequality will get changed. Inequality will get changed. So here 1 greater equal 1 upon square root of 1 plus x and 1 upon square root 2. Okay, then we multiply by x square. Multiply by x square. Inequality remains as it is. So here we have is x square is greater equal x square upon square root of 1 plus x greater equal x square upon square root 2. Okay, now integrating this inequality with respect to x, integrating from 0 to 1, integrating from 0 to 1 with respect to x, integration 0 to 1 x square dx greater equal integration 0 to 1 x square divided by square root of 1 plus x greater equal integration of 0 to 1 x square upon square root 2 dx. Okay, so this is the inequality, and we find the integration on this left hand side and this right hand side. So its integration is, if I solve this integration, the value of this integration becomes 1 by 3 is the value of this integration, and it is greater equal integration of 0 to 1 x square dx whole divided by square root of 1 plus x, it is greater equal, and the value of this integration is 1 upon 3 root 2. So this is the required inequality. Okay, so let us take one homework for you. Homework, so write down the question. Show that pi square upon 36 is less than or equal to integration over 0 to pi by 3 of the function x upon sec x dx, and it is less or equal to pi square upon 18. Okay, so try to prove this inequality, and to solve this problem I would like to give one hint for you. Okay, so hint is that the sec x function, sec x, this function is always greater or equal 1 and less equal to for all x belongs to closed interval 0 comma pi by 3. Okay, this is the hint and it will useful to solve this problem, and this is the end of this lecture. Thank you very much.